All right, everybody. Hello and welcome. Thank you for coming to Build, and thank you for coming to this session in particular. My name is Drew Barron. I'm lead program manager in the Windows Wireless team, and I'm here today to talk to you and tell you about some of the innovations and investments that we've been making in the area of Wi-Fi networking in Windows 8. Now, we've made a large number of investments, and I'm not going to be able to cover everything. But today, I am going to tell you about what we've been doing in the area of power and how we've improved the power efficiency of the Wi-Fi stack. I'm also going to tell you about how we've been focused on connection performance timing and getting the timing down so you can immediately pick up a device and be connected. I'll also tell you about how wireless plays a very important role in connected standby. And lastly, we've been traditionally very good in infrastructure connectivity and getting you connected to the internet. I'll tell you how we're expanding Wi-Fi's role into the area of device connectivity. Now, what I'm hoping you walk away with is an understanding of the scenarios that we're enabling in Windows 8 and some of the experiences around them. And for the hardware makers in the room, and I know there's quite a few of you here, I hope you understand what it takes to build those scenarios, the values of those scenarios, and the tools and collateral that we've put together to help you not just enable those scenarios, but really light them up. Now, I want to take a step back a little bit to where we are early on in Windows 8 planning. We looked at the landscape, and we noticed a number of trends that were occurring. And there were some trends that really popped out for us. These trends have really shaped the way that we've designed Windows 8. And it shaped our investments. The first of those trends is just the explosion of form factors for wireless devices. If you look at my own home, I've got multiple gaming consoles, multiple smartphones, slates, tablets, PCs, e-readers. Everything's connecting over Wi-Fi in my home. And the interesting thing about this profusion of devices is every time a new device like this comes along, it makes us rethink how we use it, how useful that device is, how we use it in daily usage, and what our expectations are around using those devices. Our expectations are changing. Devices are becoming simpler. One of the biggest expectation changes is the ability to actually pick up a device and immediately begin using it in a connected fashion. You pick up that device, you're able to check your stock, your weather, your sports scores. You can do that immediately. This is a big shift from where we were just a couple years ago. Another major trend, just the ubiquity of Wi-Fi on PCs. Now, we're investing just as much in mobile broadband connectivity as we are Wi-Fi connectivity. But in the near term, you're not going to see the penetration rates on mobile broadband that you will in Wi-Fi. You're going to see 99 to 100% of adoption in Wi-Fi. So, for the foreseeable future, Wi-Fi networking is going to remain the predominant means of connecting wirelessly to the internet. Wi-Fi is going to remain the wireless workhorse. And then lastly, fourth trend, is that if we're talking about form factors that are getting smaller, lighter, thinner, we're also talking about batteries that power these devices that are getting smaller, lighter, and thinner. So we have to be very judicious about what we do in the area of power, and we have to be very careful about what we do for power usage. So these trends really shaped our thinking and shaped the investments that we made and shaped a lot of the topics that I'm about to tell you about. Now, if you went to Billy Anders' presentation yesterday, he gave an overview of mobile broadband and Wi-Fi. And he said that we designed it with three major principles in mind. Now, this session is going to focus on the first two principles. A simplified user experience. And by that, I don't mean a lot of UX, a lot of interactive UI, that sort of thing. What I'm going to be talking about today are a lot of the underlying technologies that take place in order to enable those experiences. I'm also going to talk about how we're being smart about networks, getting you connected to the right network at the right time. So let's go ahead and focus on some of our fundamentals. Power is the first place that we're going to start. Now, for power, we've been focused on power all across Windows 8. But the wireless team knew that we had to focus on power in regards to the wireless device itself. And the reason is that ubiquity that I spoke of earlier. It's on every device. It's going to be in use on every device. So efficiency in that area is really important. Now I'm going to show here, and I'm going to walk you through what's basically a simplified stack. On the bottom, we've got the Wi-Fi device, the hardware. That's the hardware, the physical hardware, as well as the firmware that runs it. Right above that, I've got a boundary line, and it's a very important boundary line. And I'll get back to that in a second. Above that, we have the driver that communicates to the hardware, and then to the rest of the operating system, the wireless services above it. Now, that boundary is important because everything that happens above that boundary is essentially processing that happens on the main CPU on the PC. That's the big CPU. That's your general purpose application processor. And that CPU utilizes a fair amount of power to do its computing. So we looked at the problem, and we looked at how we could go about reducing what's coming across that boundary and therefore gain power efficiencies by allowing that main CPU to go to sleep more. Okay? We came up with 3 techniques to do that. The first technique is automatic power save. Now, this is power save mode that's standard in 802.11. This is where the access point's able to buffer up some frames and periodically send those to the client. From the client perspective, you're able to shut your radio off, come up every so often, grab those frames, and then shut the radio down. It's very efficient for the client. Now, we haven't changed the protocol. But what we have changed is our implementation of it. We used to, in Win 7, monitor and try to manage power save mode and just manage the overall power save mode settings. Now, in Windows 8, we changed that. It's now the responsibility of the Wi-Fi hardware itself. And there's a reason for that. In order for us to maintain that knowledge in the service, we actually have to get a stream of information from the hardware. And by getting that stream of information from the hardware, we end up going down and crossing that boundary. So in order to implement power save mode in Windows 7, we're a little bit less power efficient because we have to cross that boundary. So by moving this responsibility to the hardware, it's in a perfect position to perform power save, and it's also in a more efficient position to do so. Now, the second place that we invested is we looked at everything that was coming across this boundary. And we realized that for any given piece of data payload, let's say just one frame, one packet, we would see a packet come across this boundary, and we would see 1 or 2 interrupts to the main CPU, and the packet was processed. That's a pretty fair number. But we saw that in some instances, there were 10 times the amount of interrupts. Okay? So what we did was we looked at our telemetry. We invested in a set of tools. We invested in a set of techniques that allow the device to be far more efficient about it. Now, in a best case example, in working with one of our partners, we've been able to get the number of interrupts that are crossing this boundary for a given payload down by 5 times. So it's a really good win. Now, the third thing that we did to try to reduce what's coming across the boundary is what we call packet coalescing. In Wi-Fi networks, there's a lot of broadcast traffic. And that broadcast traffic comes in intermittently at any time. In more condensed and packed networks, there's more traffic. Every one of these frames has to be passed up and processed. But in working with hardware partners, we've devised a solution where the hardware can now invest and buffer up some of those packets and then send them up in a batch. So instead of getting, say, 10 interrupts over a second interval, the hardware can now buffer those frames and send them up maybe once, maybe twice, maybe 3 times per second. So you can drastically reduce the number of interrupts that are actually hitting the CPU and being processed. Now, power is one of those fundamentals that we focused on. And you saw, if you saw the keynote, you saw Steve Sinofsky say that we're focused on fundamentals. And we are, and this is one example. Another example of how we're focused on fundamentals is we focused on our connection performance timing. We know that people want to be able to pick up a device, use it immediately, get your stock weather in sports. All right? We looked at where we were early on in Windows 8, and we realized we weren't quite there. We did a great job in Windows 7 of getting connection timing much faster, but we weren't quite there to enable that experience where you just pick up a device and start using it because you're already connected. We realized that we had to attack this problem from two directions. The first revolves around our Wi-Fi service. Now, our Wi-Fi service has a lot of rich information. We know about the networks that you're interested in. We know about your home network. We know about your work network. We know about your hotspots. We know about your neighbor's network, with their permission, of course. But we have a lot of rich information. What we've done in Windows 8 is we've taken the critical information that we have, provided that to the Wi-Fi hardware so that it is enabled to be optimized and perform scanning and other techniques quickly and rapidly. So instead of scanning 40 channels and taking 4 seconds to scan all those channels, with the information that the Wi-Fi hardware has now, it's able to reduce that set, taking maybe 100 milliseconds or so, or even tens of milliseconds, just depending on the case, and finding the interesting networks. Okay? It's a very big reduction in the amount of time it takes to find and connect to networks. The other part of our attack had to be in our own software. Now, there's a lot of code that runs actually when you do connection. There's the Wi-Fi service gets involved. There's DHCP address acquisition. There's our network identification logic. There's proxy detection. There's a whole host of things that happen right at that point of connection. Now, we took almost 24 optimizations and improvements, and we reduced timing, and we improved the speed through those software paths. Okay? Now, what I'd like to do now is actually I'd like to step over and show you a little bit of demo about how fast we think we are now. And let me switch over. All right. Make sure I got this centered. Okay. What I'm showing here is just a Windows 7 piece of hardware. There's nothing optimized about it too much. Sorry that the image is a tiny bit grainy, but I hope you can still get the benefit of the demo. Now, there's only two things that are different on here. We've got Windows 8, which has those 20 or so optimizations that I talked about in our software side. And we have an Atheros driver in here, or Qualcomm Atheros driver, that's been updated to take advantage of that network list offloading. Now, what I'm going to do is I'm going to run a script here, and the script is going to do a couple of things. It actually flushes all the caches on the device, flushes the IE cache, the proxy caches, so that we're not pulling anything from disk. The second thing it's going to do is it's actually going to put the machine to sleep, and then I will resume it just by pressing the button on the laptop. And what I want you to do is watch when the resume comes back up and how quickly the desktop appears, and then IE right after it. So that's the last thing our script does, is when the network's ready, it actually launches IE. So I'm going to flush those caches, turn it off, give it a second here. Let's go to standby. All right, I got blinking lights. So I'm going to turn it on, and again, we're watching for the timing it takes between the desktop and IE launch. Okay, you saw that. It was instantaneous. They're right on top of each other. Okay, so as fast as the desktop was available, the network is available and connected. So it's a very, very fast demo, but these are all the things that took place in that very short period of time. We found the network. We connected to the network. We performed security with that network. You got DHCP address acquisition. You got proxy detection. That's all been completed. Network identification was done. And we actually launched IE, did some DNS lookups, and pulled down the Bing page. So those things all happened in that extremely short span of time. Now, this is a pretty important case for us. This is actually a case that you do 20 or 30 times a day. You take your device, you do some work, you check your email, you put it down, it goes to sleep. You pick it up again 20 minutes later and start using it again. So this is a case where you're most likely in the same location, you're connecting to that same network. So it's really important for us to make sure that we've got the timing on this very precise. So you can pick up the device and immediately begin using it. There's another case that's more challenging for us. And that case has to do with something that you do a couple times a day, actually. I drive to work, and then I drive home. So the device, your PC, it actually goes to sleep in one location and then pops up somewhere else. Radio environment's completely different. Networks are entirely different. Okay? Much more challenging case for us. But even in that more challenging case, with the optimizations that we've made in software and with the help and innovations in hardware, we're able to get the timing on that case down to just about the 1 second mark. We think we can squeeze a little bit more out of this by beta. We'll just have to see. But still, a very drastic reduction that enables you to take devices and use them freely. Just pick them up and start using them. Now, these are examples of 2 scenarios that we hope are under-the-cover scenarios, non-scenarios, right? We want power efficiency to be there so you just have a better battery life and a better experience with your PC. We want connection performance timing down as tightly and quickly as possible so that you don't actually notice that you're getting connected. It just happens under the covers. It's almost a non-experience. You just derive the benefit of having a great experience with your PC. Now, I'm going to talk about some other experiences. Excuse me. Let's say that I've taken my PC on the road, I've been working all day, and now I come home. Drive into my garage, I'm in my house. What do I expect that PC to do from a connectivity standpoint? Well, I expect that PC to connect to my home network. And in Windows 8, we're going to automatically do that for you. And we're going to gracefully disconnect you from your mobile broadband connection. Now, that has a lot of benefits. I mean, on mobile broadband, you have to pay for that connection. Most plans these days come with caps. So by transitioning over to the Wi-Fi network, I'm not going to incur cost on those plans. All right, big benefit. Let's say later on that day, I've been using email around the house. I decide at the end of the day that I'm going to dock that machine. Let's say it's got a cradle. The cradle's got Ethernet. We'll do the exact same thing. We'll quickly connect you to Ethernet, and we'll turn off, drop the connections gracefully for Wi-Fi and mobile broadband. Same thing. Next morning, I pick it up, pull it off the cradle. I'll immediately get you connected to the network. And then as you head off for work, you're going to connect to mobile broadband. So Windows 8 is going to take care of those transitions for you. Now, clearly, this is what we're choosing as the default behavior. But we've always said and always had this principle that the user's in control. The user can go and change this if it doesn't like, if you don't like. But this is where we're going to start with Windows 8. Now, the second experience that I'll talk to you about is how the PC is a very capable device. And being a capable device, that means it's got a lot of radios in it, right? You've got mobile broadband, you've got Wi-Fi, you've got NFC, near-field communication, you've got Bluetooth, GPS, maybe FM. Maybe somebody invents a satellite connection in a couple years. What we've done in Windows 8, we've provided a single experience, a single place that you can go to manage all those radios. And you can manage them individually, and you can manage them globally in an airplane mode type application. So what I'd like to do now is I'd actually like to show you a little demo on some of that connection switching and some of that radio management. Get it right? OK. So here we have, on the left-hand side, we've got the control panel. And I've blown out the radio management portion of things. And you can see that I've got a Wi-Fi and mobile broadband radios in here, and they're both enabled. On the right-hand side, you can see the list of connections. And you can see at the top, I'm actually connected over Ethernet. So this is that exact same scenario I just walked you through. You wake up in the morning, and you're going to take your device off the cradle. So I'm going to walk through actually taking Ethernet out. And what I'd like you to do is I'd like you to watch the Wi-Fi connection as I pull this out. So I'm going to try to make some noise with this so you can tell when I really do pop it out. And here we go. 1, 2, 3. OK. Immediately connected. All right? Similar to the last demo I showed you, Wi-Fi, the Wi-Fi device in here is armed with the right information and knowledge to get you quickly connected to that network. And it was immediate. It was instantaneous. Now, I wanted to simulate how I would drive out of my driveway and then get on mobile broadband. And I kind of wanted to put you guys all on a bus and take you to Disney to show that, but my boss wouldn't approve that. So what I will do, though, is we'll simulate that by using the radio management UI to pop the Wi-Fi radio off. Okay? So pretty simple, straightforward. We go back. And by the time I get back here, I'm already connecting up to AT&T. All right? We'll take care of these transitions for you in Windows 8. Next thing I'll do, again, let's pretend that we're now on the way home. It's been a long day on the road. It's been a long day at Build. I'm heading home. I'm going to go back here. I'm going to enable this device. And I'm going to try to move this mouse really, really fast to show you how fast. So here we go. Wi-Fi is already reconnected. OK? It's connected very, very quickly. That same instantaneous connection that you saw in the previous parts of the demo. Now, at this point, some of you are saying, hey, wait a second, those two things are still connected. Okay? And that's intentional. That's pretty important. When we get you connected to a network, we're very fast about getting you connected to the network. When it comes to disconnecting you from a network, we do what we're calling graceful disconnect. Okay? We don't immediately drop that connection because that would be potentially a bad experience. It'd be very easy for us to do. The logic is relatively simple, but it could be a very bad experience. Our goal here in gracefully disconnecting is to make sure that there aren't any applications that are currently using that older pipe. Okay? So we watch to make sure there's no applications using it. We watch to make sure that the traffic has died down on that link before we disconnect it. And the whole purpose here is to make sure that we preserve the user's experience. We can take a little bit of time and be a bit lossy about when we disconnect a secondary network, but we don't want to impact the user's experience if they're in the middle of doing something. All right? All right. Now I'm going to switch tracks a little bit, and we're going to talk about connected standby. We're going to talk about how wireless plays a really key role in connected standby. Wireless is actually the connected part of connected standby. Now, you might have seen it in some of the other sessions here, but connected standby is basically a new power state in Windows 8 for devices, for PCs, that have CPUs that are capable of going into very low power states and staying there for a long period of time. It's basically that state that occurs when you press the button and the screen goes off. There's a number of certain expectations that we have in that state. First, we expect wireless to remain connected. And it's wireless. It could either be Wi-Fi or mobile broadband, but for the sake of this session, we'll just focus on the Wi-Fi side. So you have to maintain a connection to the network. There's a number of things that we expect to be able to do while we're in this state. We expect live tile updates to still be able to refresh so that when you pick up that device, not only are you connected, but everything is fresh as if it was just refreshed for you seconds before you picked it up. The other thing is that there'll be certain push notification applications that are capable of registering with Windows 8 so that you can do things like send text messages or SMS and alert the user through the device that there's something important for them. So what's going on with Wi-Fi in this case? Well, in the diagram I have, we've got a basic blowout of a simplified PC. And what happens when you move to connected standby is that main CPU will actually go to its lowest power state where it can stay for long periods of time. All the other peripherals in the device will turn off, go dormant, go idle. They'll stop drawing power. The Wi-Fi device in this case is going to stay on and remain connected to the network. That's its job. It's got to maintain a low power connection. And it's also got to be able to push down patterns for push notification applications. And those patterns could be a set of filters. So it's got a very important role in connected standby. Push notification apps. There's going to be a small set of these in Windows 8. And those applications are the ones that you can imagine as being those real-time communication apps. Your email, your IM, your messaging, voice over IP. Anything that has to come into the device, even when it's in a low power state, and alert the user that some sort of action needs to be taken. Real-time apps will register, or these apps will register with our real-time communication APIs. And whenever one of these applications run, Windows 8 will plumb the appropriate patterns or filters down to the Wi-Fi device. And the Wi-Fi device has a very important role here. It actually filters out the majority of the traffic that it sees while it's in this state, but it's looking for matches. Okay? It's looking for matches for push notifications. So let's say the server here, the email server, has something important to send. Well, it sends it on the wire. It's received by the Wi-Fi NIC. It passes through the Wi-Fi NIC's hardware, through the filters. And if the pattern matches, it passes this up to Windows 8. It wakes the device up. Windows 8 takes over, pushes that information to the application, and then the application can then do something with it, like shake the device, turn the screen on, do what it needs to in order to alert the user that there's something that needs attention. So it's a very efficient, power-efficient type of setup. You have a main a PC where the CPU itself goes into low power states. The peripherals in the device are all powered off, and it's really only the Wi-Fi or wireless NIC that's still on. Now, that means that Wi-Fi NIC has to do a couple of very important things. It's got to maintain the connection to the network. It's got to be able to push and plumb patterns down for push notifications. It's got to be able to filter out everything that it sees, and then if it sees a match for those patterns, then indicate and wake the rest of the OS up. This means that you're going to see a new generation of hardware out there. You're going to see Wi-Fi chips that also come with their own small CPUs on them. They're small CPUs. They're dedicated towards processing Wi-Fi frames. But you need that sort of offloading and that processing in order for the rest of the device to remain in a very, very low power. Okay. All right. Now, I've been talking a little bit about a lot of infrastructure connectivity. And this is where we kind of change tracks. This is what we're opening up that's new in Windows 8. We're opening up the ability for Windows 8 devices to connect directly to other devices or other PCs. And this is called Wi-Fi. Sorry about that. This is called Wi-Fi Direct. So Wi-Fi Direct is a standard-based protocol. This is a WFA standard. And we like standards because with the thousands of devices that are going to be built out there, a standard helps us rally around something common, and we can ensure a certain level of interoperability. The second benefit to having a standard is that from a licensing perspective, you don't have to pay any royalties to Microsoft to license the technology. This is a public standard. Wi-Fi Direct also provides you a secure connection between two endpoints. And more importantly, on the topology side, you don't have to have a PC connect to an access point, have another PC connect to an access point, and then find each other. It's not that complicated. It's Wi-Fi Direct. It is direct discovery and direct connections between those two endpoints. But that's a little bit about the architecture. What's unique about our implementation are some of the things that we've done. And the first thing that we've done is that we build on existing Wi-Fi hardware. And by that I mean we build on the existing platform that we have in the virtualized driver model. We've had this model for at least a release in Windows 7. It's implemented by our hardware partners. We've got a very good degree of stability around it. And we build Wi-Fi Direct right on top of that. So the investments that our partners have made in our stack are bearing dividends now. That virtualized driver platform allows us to do a couple of interesting things. It allows us to maintain simultaneous connections to two things at once. So we can connect to the internet on one connection. And we can also connect to a device on another, on a virtualized connection. Now, if you think about if we didn't have a virtualized driver platform, what would that mean? Now, in order to achieve the same thing, you would have to have a PC with maybe 2 Wi-Fi radios in it, right? One that would connect you to the internet, one that would connect you to your devices. That would raise the overall cost of your Wi-Fi hardware by presumably double. The other alternative is that we would have to have some sort of experience where we say, hey, do you really want to connect to the internet? It looks like you might be connecting to this device instead. That's a difficult conversation to have. It's not a conversation that I want to have with my customers. Okay? So it allows you, this virtualized driver platform allows you to have concurrent connections. So you can be connected to the internet, you can be connected to the device at the same time without losing internet connectivity. Another way that we've invested in Wi-Fi Direct is we have a very power-efficient implementation. Now, you saw earlier in the presentation how we've looked and focused at saving power and achieving power savings. We didn't want to lose those gains when we offer Wi-Fi Direct by turning on the radio more and scanning more and just drawing power. So we didn't want to lose those gains. So our implementation is power efficient in the sense that it's only turned on and enabled when there's an application or some user experience that's driving the need for Wi-Fi Direct. So it's an on-demand implementation. We won't be drawing power. We won't be performing a lot of scanning. We won't be overall impacting the battery life on a device. It's completely user-driven. When that user has an experience that they want to drive that can use Wi-Fi Direct, then we enable it. Lastly, there's a couple of scenarios that we support that are in the box. Scenarios like Play 2 and proximity. And you may have seen in other sessions proximity shown as being able to tap to pair devices. And when you do that, you can utilize Wi-Fi Direct as a high bandwidth transport between 2 applications on those 2 different devices. The other thing, the other scenario that we support natively is Play 2. So you can actually take a Windows 8 PC and play any HD streaming content and play it to something like a set-top box that also supports Play 2 and Wi-Fi Direct, or directly to a TV. So you can stream that high bandwidth content directly to those devices. Now, this is just a high-level overview of Wi-Fi Direct. If you want more in-depth information about Wi-Fi Direct, there's a session later today. It's actually in this room. My colleague Yatharth Gupta will be going into a lot more detail on it. And if you're interested in Wi-Fi Direct, I encourage you to attend that session. Now, I've covered a lot of ground, and I've covered quite a number of scenarios that we're enabling in Windows 8, and a lot of experiences. And the question is, how do we go about helping our hardware partners not just enable those scenarios, but really light them up? Because honestly, we can't create these scenarios without the help of our partners. So whether it's Connected Standby or Instant Connect, or whether it's the power improvements that I've shown, flight mode, any of the scenarios and features and experience I've just shown, we've built out a set of collateral for our partners to use. Now, I've been working with hardware, and I've been working with our driver developers and driver partners for a long time. I know that it's a very challenging task. It's difficult work that has to be done. But we've built these things to try to make your jobs a little bit easier, to speed you through the development process so that you can then go and focus on things that are critical to your businesses. We've developed the guidance and the documentation on how to choose the right hardware, how to develop the right driver. We've also developed the testing and tools that you need to test it out and make sure that it's meeting certain levels of quality. So we've invested pretty heavily in this program. We've invested for your benefit, and we hope that you take advantage of it. Now, we've had this program for a good part of a year. We've been taking feedback regularly. We're always open to more feedback on this. And the last point I wanted to make on this is that the certification, Windows certification for Wi-Fi devices, is tailored to the type of devices that you're building. So if you are building wireless hardware for connected standby, we have a tailored approach that will guide you down that path. There we go. All right, we've covered quite a number of things. And I wanted to sum up by saying these are some of the big experiences that we have that are a lot of under-the-cover things, right? We've increased the power efficiency of our stack so that you hopefully have longer battery lives. We've reduced the connection timing performance so that you can pick up that device and immediately start using it. You know, you can undock it from that cradle, and it snaps right to the network. Wi-Fi is the connected part of connected standby. Enables you to have that device that is fresh, always up to date. And we're also opening up the avenue for you to pursue the direct device connectivity straight from Windows 8. Now, if you're a hardware maker, again, I encourage you to go look at our certification program for Wi-Fi devices. Again, we've spent a considerable effort to make sure that we've got the testing and tools that you need to make sure that you can speed along your development. And the last point I did want to make on this is that in Windows Update, please consider Windows Update for driver serviceability. Sometime we will ship Windows 8, but our customers will keep picking it up after that for years. And we want to make sure that we've got the latest, greatest, stablest drivers that are out there in the ecosystem. So no matter when you pick up Windows 8, you have an excellent experience. Now, I mentioned a couple of sessions. The first 2 sessions have actually already taken place. Those are yesterday. But you can always look them up on the on-demand sessions. The next 3 are happening later today. I mentioned the Wi-Fi Direct session. And if you want to understand more about connected standby, there's 2 great sessions on that. I've only been able to show you a small slice of what connected standby does and is. It's part of a larger picture. There's far more integration with, say, apps. There's other sessions that will help you get the knowledge that you're looking for. Now, in your soft copies, I know you've got access to these links. But if I can't answer your questions satisfactorily today, you can always email windowswireless@microsoft.com, and we will do what we can to answer your questions. So I'll take questions in a second, but I just wanted to say thank you very much for attending this session, and thank you for coming to Build. All right. If we want to take questions, if we could step up to the mics. There are some mics in the back of the room. We're going to start over here.
I'm wondering what the impact of VPNs is on this automatic connection management, and whether or not there are any requirements placed on third-party VPN vendors to ensure that they don't confuse the connection manager with what appears to be a link that would suppress wireless.
Mm-hmm. That's a good question. VPNs naturally have to take advantage of what underlying connections they have available to them. And the only thing that we're doing differently here is we're making sure we're on the network that we think you ought to be on in Windows 8. Those VPN connections have to adjust to the fact that connections change all the time. So I imagine that they're just going to have to adjust to the fact that there might be some differences in the connection from time to time. So it's the same set of connections that'll be coming up and down. You just might see it more frequently in Windows 8.
I'm specifically asking about what the wireless connectivity management, the thing that's doing the decision about whether to drop wireless connections, for instance, in the docking scenario when it sees an Ethernet.
Yep.
What VPN vendors have to do to make sure that they don't look like an Ethernet and cause all the wireless connections to come down?
That's a good question. Honestly, I don't have the answer to that question. But if I could get your business card and that question, I'll take it up and I'll find the right answer for you.
And second question is with respect to IPsec secured services over the link. How does that impact, or is it impacted by this connected standby mode? If, for instance, the connectivity, which might be carrying the push notification, is secured by IPsec.
As far as I know, IPsec's not affected by connected standby. It survives.
Is the pattern language constrained enough? Is constrained such that it wouldn't necessarily be able to recognize a secured packet coming across?
No, I believe you'll still be able to send those sort of frames. Yep. On this side.
Hi, so I had a question on the Wake on Wi-Fi.
Yep.
Is this all on the client side, or is there any server requirements to wake up the client?
No, Wake on Wi-Fi is purely a client-side implementation. So it is something that the Wi-Fi hardware has to be able to process, match patterns for push notifications, and then indicate the appropriate wake response up to the operating system. Yep. Okay, one question over here.
Had a question about USB connected networking. A lot of desktops use USB to connect radios into systems. So how does the connected standby work there?
Let's see. For USB connections, I believe it falls outside. I don't believe that those connection types, if it's an add-on, are going to be capable of being able to support the connected standby cycle. Connected standby is for a lot of Wi-Fi devices and mobile broadband devices that will be embedded in the systems.
Well, a lot of desktops have embedded, but USB based.
That's true. Yep.
So you're not supporting that at all.
We're supporting USB connected systems, but in connected standby, you actually need specialized hardware in order to achieve that. So I don't see that type of hardware actually being on desktop systems. Okay. So I don't think the two actually come together. All right. All right. Any other questions? All right, that's it. Thank you very much for coming to Build.